Okay, hi everyone. In this video here, I'm going to work on a couple of problems that have to do with uh, finding a weight, a particular weight that corresponds to the 10% highest or heaviest. You've seen these similar problems, or the 10% lightest or shortest, for example, of some normal distribution. So here I'm given a normal distribution of weights of boxes, and the mean is 60 and the standard deviation is 10. So here I want to find, let's look at C here, the weight that corresponds to the top 10% lightest boxes. Okay, so what does this mean? This is the maximum weight. So this means that here I have created my normal distribution of these weights. 60 is in the middle because this is the mean. Okay, so the lightest boxes are here to the left. Okay, so I'm looking for what value here corresponds um, to having 10% of, of these boxes in this distribution being the lightest. So here I'm really looking for, I have an area of 0.1 or 10% because this area is 1 under the standard normal curve. So the area I have here is, I'm looking for an area of 10%, and what value does this correspond to, this area of 10%? So this is kind of the inverse of what we were doing in other videos where we had a particular x value and we were looking at areas or probabilities to the left. Okay, so here I have the area or the probability of less than 10%, and I want to find what weight this corresponds to. So Excel has a formula to help you with this, and it's called norm in. Okay, and here you give it the probability to the left. It's always to the left. Okay, so it's 0.1. In this case, 10% corresponds to 0.1. The mean is 60, and the standard deviation is 10. So this gives me a value of 47.18. Okay, so here it is, 47.18 is right here. So if you take all these weights, so any box falling under 47.18 pounds is actually in like the bottom 10% of these boxes in terms of weight. So now let's look at the other problem here where it says to find the minimum weight of the top 10% heaviest boxes. So here are the heaviest boxes on this right hand side here of this distribution, the right part of it. So it says what weight, what is like the minimum weight here, which corresponds to the highest, the top 10% heaviest boxes. Okay, so we really have here, we're given the area to the right. Okay, so the area to the right, or this tail here, is 0.1. Okay, and we want to find what value does this correspond to. Now, for us to use this formula in Excel, we need an area to the left. Okay, we're going to use the same formula that we did before, the norm in formula. But remember, this formula always works with an area to the left. Okay, so we know the area to the right, but it's so easy to find the area to the left because we just do 1 minus the area to the right. Okay, so if the area to the right here is 0.1, then the area to the left is 0.9 because 1 minus 0.1 is 0.9. So here, if we use again the norm in formula and we put for probability, probability is area, again under the normal curve. So here we put 0.9, a mean of 60 and a standard deviation of 10. We find that 72.82, here it is, 72 pointed somewhere here. So we find that all boxes weighing over 72.82 are in the top percent heaviest boxes in our distribution here. Okay, thank you so much.